So here we will try to, you can say, uh, a particular part of discussion will do an exploration of Olympiad Combinatorics by Roshil Mathur. This book I have taken into consideration, and I will try to discuss this. Okay, I'll try to discuss this in our discussions. So timing, etc., is known to you. Let us start with a question. A question I am taking from this particular book. We don't have any pressure to go very fast. We can take a question and randomly we can start a question, and let us say if you are able to solve it, it is well and good. If you're not able to solve it, better we'll just retry for 3 trials. Okay. So yeah. So let me write the question first. What is the question? We should be knowing the question first. Okay, this color is not proper, so I'll just yeah, that will be fine. And this is also fine, so I'll just use this one, I think. So this is a question I'm going to use. Two prisoners. Okay, I'll just try to rule the lines I'm going to use here. Okay. So two prisoners, two prisoners, two prisoners are given the following condition. The following condition, situation or condition we can say. They must go to different rooms with no means. They must go to, they must go to, go to, they must go to, so okay. They must go to, so let me do one thing. Let me just erase this and write in some other way. Okay. The question is like this. The question is very straightforward. Two prisoners are given. Two prisoners are the following situation. the following situation. They must they must this should be used, yeah, as per my understanding. They must go to different rooms. They must go to different rooms. They must go to different rooms with no means of contact. With no means of contact, okay, with the other person, with the other person. Both of them toss a coin. So two prisoners are given the following situation. They must go to different rooms with no means of contact with other person. That's fine. Both of them, both of them, both of them toss a coin, toss a coin after which they must guess the result of the other person. Both of them toss a coin after which must they must guess the result. The result They must guess the result of the other person other person of the other person if at least one of them if at least one of them guesses the result of the toss correctly. If at least one of them guesses guesses the result of the toss. So it's such a long question. I'll do one thing. I'll not write it. Unnecessary time consumption is in writing. So I'll do one thing. I'll just solve it. And it is a book. Can be purchased by the persons who are looking at this video can purchase this obviously, and can go for this particular part. Okay. Right. Okay then. So it is problem number 8 on page number 4. It's actually problem number 8. Problem number 8, and it is page 4. Okay. And the book, the same book we are using here. The question says that two persons are given the following situation. They must go to different rooms with no means of contact with the other person. Both of them toss a coin, after which they must guess the result of the other person. If at least one of them guesses the result of the toss correctly, they both are free. So both of them will toss a coin, and different rooms they are been taken. So I'll say, let us say these rooms are like this. Is one of the rooms, and the other one, again one of the rooms are there. So both of them are inside the room, which is different rooms are there. Person one and person two. We can assume like this. So person one, this is for person one, and this is for person number two. Okay. Now what happens? Both of them toss a coin, after which they must guess the result of the other person. Tossing of coin is there, and we don't know what will come here. Either it can be head or tail. It can be head or tail, head or tail. And guessing, if let us say guess is correct, so it will be anyone guess if it is correct, obviously they both are free. So I can say P1 if guesses that yes it is head here and it is actually head there. So head or tail will come into picture. There is a half probability of guessing that correct. If let us say head comes in the first person's part and we are guessing tail, so there is a probability of 50% of getting tail also, right? This half is there, is half is there. In this case, it is also half and half because we are not sure, right? So if at least one of them guesses the result of the toss correctly, they both are free. Show that by discussing a strategy beforehand, the prisoners can guarantee freedom. Show that by discussing a strategy, what strategy we can use beforehand. Uh, what strategy we'll use beforehand, the prisoners can guarantee freedom. Now, prisoners can guarantee freedom is the question here, right? Let us read the question again. Two prisoners are given the following situation. They must go to different rooms with no means of contact with other person. Both of them toss a coin, after which they must guess the result of the other person. If at least one of them guesses the result of the toss correctly, they both are free. Show that by discussing a strategy beforehand, the prisoners can guarantee freedom. We have to just define a strategy here by which both are free. And what can be the strategy that we have to work actually? Okay. What will be the strategy here that we have to work on that? So if you go inside the rooms, there is no contact. A few conditions which are mentioned here, I can say. No contact is there. No contact is there whenever they are inside the rooms. I'll just mention with some other color here. So there is no contact inside the rooms. And inside the rooms, what strategy we can apply so that they are guaranteed free? So for that, obviously, whatever the guest will do, one of the person will do. It will. So coin tossing we are doing, and coin tossing is a event we can't change. So obviously, coin tossing will be done in both the rooms, room one and room two. Let us say will cause a coin. Either we can get head or tail. Let us say we are getting head here. So both can say that head will come. So because in that case also tail can come, no? If you're tossing a coin, there is a probability of tail coming up in both the cases. So what are the possibilities? Let us say first coin toss, there are some possibilities. In coin toss, what are the possibilities? Tail will come here, tail will come here. Head will come here, head will come here. Tail will come here, head will come here. And so, yeah. So like this, we can try to solve it. Okay. Tail, tail we have done. Head, head we have done. Tail, head we have done. Head, tail we have done. These are the four possibilities we can say. So they will, if say that tail is coming up. So both will be correct here. If any one of, if both will say, both says T, then it is freedom is there, right? Then we can say freedom is there in this case. Then we can say freedom, it will lead to freedom. Okay. Then it will lead to freedom. Very high. Okay, I have to purchase that. I think it is very, very important for me. Otherwise, issues will come up. So, okay, so much high task is going on. So that's why consumption, it is there. So freedom is there. And whenever both are saying, both says H. So both is tail here. So what are the cases we have to find? By a strategy, beforehand the business can guarantee freedom. So if they say tail here, it will not work out. If they say tail here, both say tail here, no freedom. It is no freedom. Okay, this freedom is there. And if they say tail here, that's absolutely fine. Say tail here, absolutely fine. So either both should say the same thing. Only one case we are having, it is not guaranteeing the freedom. Out of the four cases, we have four cases possible. And out of the four cases, I can say three cases are possibilities that they will be free. Only one case we are having that will lead to some other things. So if I say first one will say head, second will say tail. In that case, first will this will be free. Let us say this is the set of one possibilities we are discussing. Let us now discuss some other possibilities. Okay. This will not actually lead to the final conclusion result. I will say for this one case issue is there, right? One case issue is there. Let us say the second possibility. So head tail is coming up. Head tail, let us say it is fixed for all the cases. Head tail, head tail. Again here one issue will be there. A guaranteed freedom I can't say, because head tail, if you're saying in the first case it is fine, it is free. Head tail, if you're using the second case, it is also free. Okay. Head tail, head tail, head tail, for the third case it is not working because it is just opposite. So, and head tail, it is working here. So I can say again, if you say the same thing or a different case, again guaranteed freedom is not possible here. strategy beforehand the prisoners can guarantee. I don't think any strategy is possible at this moment. Uh, this is possible if you just take because we have taken both tail together or both head together, also the same thing will apply. And head tail we have taken, tail head also if you take, the same thing will apply here, or same case will apply here. Means that if we take head together, tail together, head tail or tail head together, same thing will apply. It means that there is one loophole in every strategy. As per the current discussion what I am doing right now, I can see one loophole is there uh, in the cases, right? Because possibility is that tail will come into picture, head will come into picture, tail head can come, head tail can come. Like this, possibilities are there. So I can say two options I've tried, but the problem is I can't figure out how to proceed further from this. Okay, so I can say that we need to work out on this. Either we take head or tail. So let us say both the predictions say tail they are taking. So there are three cases where there is a possibility to be free. 100% guarantee is not there. How can one guarantee that is the case? I think guarantee is not possible, but it is possible that head if you're telling, tail if you're taking, head tail or tail head we are taking. In that case, one issue will be there every time. If you're taking tail, so for the tail, second case will be issue. Okay, wherever we are having head here. And if you take a head, the first case will be the issue. If you take a tail head will give, you can say, fourth case as the issue. And head tail if you're taking, third case will be the issue. So guarantee is not possible. 75% possibility of free is there with every possibility is there. 75% only. 100% is not there. This kind of strategy before the prisoners can guarantee freedom. Guarantee freedom, sorry, we can't have it. Okay. This question I've tried, and as per my understanding, it's not possible. Let me now understand how it works out. Okay. Because I can't see anything here. Okay. This is the first trial I have done. I'll just retry this particular question again. Okay. I'll just mark this question and I retry this question. I'll not conclude at the moment because I don't know what is the final answer for this. But as for me, there is a 75% possibility to be free. 1/4 every time you have the possibility that it is not, we can't be free. Okay. So no problem. First trial we have done. And I'll just try it again. Because I don't want to check the answer. What is the answer right now? It is possible that it is correct. It is possible that it is incorrect. But I don't want to try at the moment because I want to retry this question. Okay. So if you want to try, obviously you can go ahead. Okay. Well, so this I'll just stop the discussion for this question here itself. Okay. So yeah.